Welcome to IAS Prep Corner, your free gateway to cracking UPSC. Today, we begin part 1 of our topic, Shape of the Earth. Let's explore how our understanding of Earth's shape has evolved through history. In ancient times, people believed the Earth was flat. There were even stories that those who sinned were pushed off the edge. This belief came from the visible horizon and lack of knowledge about Earth's actual form. Greek philosophers like Thales in the 7th century BCE were among the first to propose that Earth is spherical. Later, Pythagoras and Aristotle supported this with logical arguments, marking the shift from myth to reason. Science redefines our place in the universe. During ancient and medieval times, people widely believed that the Earth was flat and at the center of the universe. However, scientific thinkers began to challenge these notions. Copernicus, heliocentric revolution. Nicholas Copernicus, a Polish astronomer of the 16th century, supported the spherical nature of Earth. He introduced the heliocentric model, the revolutionary idea that the Sun is at the center of the solar system, and Earth revolves around it. This challenged the long-held geocentric view and paved the way for modern astronomy. Aryabhata, ancient Indian wisdom. Aryabhata, 5th century CE, a brilliant Indian mathematician and astronomer, had already stated that the Earth is spherical. It rotates on an imaginary axis, causing day and night. His insights were centuries ahead of their time and laid the foundation for astronomical science in India. Why it mattered? These ideas were critical because they moved explanations from mythology to science, encouraged observation, reasoning, and mathematics to explain celestial phenomena, helped shift human perspective from Earth being the center of everything to being part of a vast, structured cosmos. Magellan's voyage marked the first successful circumnavigation of the globe, a monumental achievement that confirmed the Earth's roundness. Although Magellan was killed in Mactan during a tribal conflict in the Philippines, his crew pressed on. Under the command of Juan Sebastián Elcano, the expedition completed its journey in 1522, returning to Spain and making history. Isaac Newton demonstrated that Earth is not a perfect sphere. Due to the Earth's rotation, a centrifugal force is created, causing the planet to bulge at the equator and flatten at the poles. This shape is called an oblate spheroid, slightly squashed at the top and bottom. As a result of this shape, gravity is stronger at the poles, where you're closer to the center of the Earth. Gravity is weaker at the equator, due to the bulging and centrifugal force from Earth's spin. This discovery was crucial in understanding Earth's true geometry, and it helped lay the foundation for modern geodesy and planetary science. Gravity is the force by which objects attract each other. The greater the mass, the stronger the gravitational pull. For example, the Sun has a huge mass, so it exerts a strong gravitational force, keeping the planets, including Earth, orbiting around it. Similarly, Earth's gravity holds the Moon in orbit. This principle also affects Earth's own shape. The mass of the Earth pulls everything toward its center, which is why planets tend to form into rounded shapes. However, due to rotation, Earth becomes an oblate spheroid rather than a perfect sphere. Thus, mass and gravity together shape planetary bodies, influencing not just motion, but form. The Earth's actual shape is called a geoid. It is not a perfect sphere and not flat either. Instead, it's a shape that bulges at the equator, due to Earth's rotation, and is irregular across the surface, because of mountains, valleys, ocean trenches, etc. The term geoid literally means Earth-shaped, where oid means resembling or like. So, a geoid is a model of Earth's shape that closely follows the actual surface, including gravitational variations caused by uneven mass distribution, like dense rock or deep oceans. This concept is important for accurate satellite navigation, sea level measurement, mapping and geography. In short, while globes are helpful, the geoid gives us the most realistic picture of Earth's complex form. Geodesy is the scientific study of the Earth's exact shape, its position in space, its gravity field, and how all of these change over time. It helps answer questions like, What is the true size and shape of the Earth? How is Earth tilted and positioned in space? How does gravity vary in different regions? Is the Earth's surface rising or sinking due to tectonic movements, melting glaciers, or earthquakes? Why is geodesy important? It enables precise GPS navigation. It helps track sea level rise and climate change. It supports mapping, surveying, and space missions. It provides critical data for natural disaster monitoring, like earthquakes and volcanoes. In short, geodesy is the foundation for understanding how our dynamic Earth behaves, not just now, but how it's evolving into the future. Proofs that the Earth is spherical. Over time, many observations and experiments have confirmed that the Earth is not flat, but spherical, round like a ball. Here are the main proofs. 1. Circumnavigation. Explorers like Magellan successfully sailed around the Earth. This proves you can go in one direction and eventually return to the same place only possible on a round planet. 2. Circular horizon. When standing on a high point, the horizon always appears curved, not flat. This gentle curve is the edge of the spherical Earth you're seeing. 3. Visibility of ships. When ships approach from the sea, you first see the mast, then the body of the ship. This happens because the ship is rising over the curved surface of the Earth. 4. Sunrise and sunset patterns. The sun rises and sets at different times in different locations. This time difference is due to the Earth's curvature and its rotation. 5. Lunar eclipse shadows. During a lunar eclipse, the Earth's shadow on the moon is always round. Only a spherical object can cast a consistently circular shadow from any angle. 6. Other planetary shapes. All other observed planets, like Mars, Jupiter, and Venus, are spherical. Since Earth is also a planet, it logically shares the same shape due to gravity. 7. Aerial and satellite photos. Modern satellites and space missions have taken thousands of images of Earth from space. These clearly show a round Earth with a curved surface. Snowflake 8. Behavior of poles. At the poles, the stars rotate in circles directly overhead, which is only possible on a curved surface. On a flat Earth, the stars would move in straight lines or unusual paths. These consistent observations from ancient explorers to modern scientists all support one conclusion: Earth is a sphere, slightly flattened at the poles and bulging at the equator, but round nonetheless. From flat Earth to geoid, how our understanding evolved. For much of human history, people believed that the Earth was flat. This idea was based on limited observations and early myths. However, over time, scientific inquiry and real-world evidence helped us understand the true shape of Earth. Ancient thinkers challenged flat Earth beliefs. Thales of Miletus, 6th century BCE, was among the first to suggest that natural causes, not mythology, explain the universe. Aryabhata, the great Indian mathematician and astronomer, 5th century CE, stated that Earth rotates and is round like a sphere. His ideas were revolutionary for his time. Isaac Newton later explained that because of Earth's rotation, it's not a perfect sphere, it's flattened at the poles and bulging at the equator. This led to the concept of Earth as a geoid. What is a geoid? A geoid is Earth's actual shape, slightly irregular, shaped by terrain, and influenced by gravity. It's not a perfect sphere or flat. The word oid means resembling a shape, in this case, resembling a sphere but more accurate to Earth's real surface. Real-world observations support this. Satellite imagery and space missions clearly show Earth's round form. Eclipses, time zones, airplane routes, and ocean horizons all support a spherical, rotating Earth. The science of geodesy now measures Earth's shape, gravity, and motion with precision. This was part 1 of our Earth series. In part 2, we'll learn about Earth's axis and its movements. Don't forget to like, share, and subscribe to IAS Prep Corner. IAS Prep Corner is here to empower UPSC aspirants with completely free, quality education. Follow us for regular updates and top-tier preparation.